Before we get started into what we're going to talk about today, I just wanted to review a little bit. So if I ask you to graph this quadratic equation, we know it's quadratic because of the square. Right, that tells me it's quadratic. That tells me it's a parabola. And then we know it's been shifted right 3 and down 1, just using transformations. So I'm going to go right 3, down 1. And then from there, if you look at there's a 1 in front. So if you think about, there's no stretch or compression in it, and it's positive, so it's opening up. So if I go 1 squared is 1, so over 1, up 1. 2 squared is 4, so I go over 2 and up 4. And then if you think of that axis of symmetry going down there, right, that helps us to get these other points. There's going to be a point right over there. Okay, we draw the parabola that passes through there. And we have our graph. And we can do all of that just using transformations. Usually this is referred to as vertex form of a quadratic. And the reason why we refer to it that way is because I can just look at this, right? And I can tell that it's right 3 and down 1. So the vertex is right 3, down 1. So there's my vertex. So just by looking at the equation, I can tell what the vertex is equal to. Well, it turns out quadratics don't always come in vertex form. Like there's other forms you can put the equation in. So I want to show you another one of those forms, and we're going to talk about that today. So if I take this equation, and you don't need to write this down in your notes or anything, just watch. But if I take this equation, and I'm just going to multiply out the x minus 3 squared. So I get y equals, and remember when you multiply that out, x minus 3 squared is x minus 3 times x minus 3. All right, then I'm going to just multiply this out. I still have the minus 1, but I'm just going to distribute here. That's x squared minus 3x minus 3x plus 9. So now I get y equals x squared minus 6x plus 8. So this and this are the same thing. They're the same quadratic function. This one is in what we usually refer to as vertex form. What we usually refer to this one as standard form. Well, we want to be able to, one of our goals for today is we want to be able to switch back and forth. We already know how to multiply out x minus 3 squared. We know how to do that. We know how to combine like terms. So we know how to go from vertex form to standard form. We've already done that. What we're going to focus on is if you're given the equation in standard form, if we can work backwards and put the equation in that vertex form. And that's really valuable to us because if I look down here, look at the y equals x squared minus, I've got an x on that, sorry. X squared minus 6x plus 8. I can't tell what the vertex is by looking at it. But if I could take this equation and rewrite it in vertex form, then I could graph it really easily. So when we go to graph, it's nice to have it in vertex form. So that's what we're going to focus on right now is how do we go from standard form to vertex form, excuse me. So really quick, just to review, this is vertex form. And when you have it in vertex form, we know that this shifts it right or left. So the reason why I call this vertex form is because my vertex is, if it's a minus h, that means my x-coordinate is going to be a positive h. And that's going to shift it up or down. So that's going to be the y-coordinate. So just by looking at that equation, if I know what h and k are, I know what the vertex is, which makes it really easy to graph the parabola. This is standard form. So standard form is when it's all multiplied out. So I take the x minus h squared, I multiply it out, I end up with ax squared plus bx plus c. So what we're going to focus on today is taking something that's in standard form, and we want to take it and we want to be able to switch it to vertex form. Okay, so for just a second, before I start on that, I just want you to look at these 5 problems. So I want you to pause the video, look at these 5 problems, and just decide which one of these are in vertex form and which one of these are in standard form, and then come back and we'll talk about it together. So this first one, right? This one matches this one. Okay, this one is in standard form. This one is in vertex form, right? It matches that one. By the way, the vertex of that one is, you're going to go left 4 and up 4. So that's where my vertex is right there. This is also vertex form, right? It looks like that one up there. This vertex would be at -4, +1. This one is in standard form, right? It looks like that x squared plus, x squared plus x plus a constant. This last one's a little tricky, so I don't know what you came up with, but I think we could actually argue that it's both. It could be like standard form, kind of like this, 2x squared plus, kind of like having a 0x in the middle, right? That's the same as that. So I think it could totally be standard form. I also think you could think of that equation as being this, where there's no left and right shift, right? There's no horizontal shift, but there is a vertical shift down 3. So this one I think actually is both. Like that is in both vertex and standard form. That's kind of a special case there. Okay, so now that we know the difference between vertex and standard form, again, what we're going to focus on right here is our learning goal, is I can change quadratic functions from standard to vertex form. So we want to take the standard form, change it to vertex form. And once we have it in vertex form, that allows us to graph it. Okay, so let me go through this example with you. So I want to take this equation and I want to make it look like this. I want it in that vertex form. So this is the process. So I start out, I group the x squared and the 8x together in parentheses, leave a little bit of space right there, and I put the plus 11 on the outside. So I haven't changed the equation, I just changed the form a little bit. Okay, now what I want to do is I want to fill in some number right here that's going to make it so that this factors to be a perfect square. See this right here is a perfect square, x minus h squared. So that's like saying, x minus 2 squared. Well, that's x minus 2 times x minus 2. Or it could be, I don't know, x plus 7 squared, which really means x plus 7 times x plus 7. So what I'm trying to do is make it so this is going to be an x and an x. I want to add the right number right here. Right, I'll highlight it. I want to add the right number right here so that this will factor to be a perfect square. Well, remember the two numbers have to add up to be 8, right? You have to times them to get the last number, and they have to add up to be 8. So it has to be a 4 and a 4. So it's got to be x plus 4 and x plus 4. So 4 times 4 is 16. So I need a 16 right there so that this will factor to be a perfect square. Now the problem with that is if I add 16, it's not the same equation anymore. So I need to somehow compensate for that. So what I do is if there's a plus 16, I know on the outside I can just put a minus 16 because what happens there, right? 16 minus 16 is 0. So I haven't actually changed the equation. I've changed what it looks like, but it's still the same function, the same equation. Okay, now I'm almost there. So my last step is this, y equals, I'm just going to factor this x squared plus 8x plus 16. Well, it factors to be x plus 4 times x plus 4. It's a perfect square. That's what we wanted. So x plus 4 squared. And then out here I have that 11 minus 16. 11 minus 16 is a minus 5. I get down here. That now looks like this, right? Now we have it in vertex form. We're not going to take the time to graph it, but we could, right? We know the vertex, I'm going to go left 4. So the vertex is left 4. And down 5. That's where my vertex is. And I know that it's opening right up because there's a positive 1 in front. So we could draw that if we had to, but I think we're good with that. Okay, let me go through another example. So I got this x squared minus 4x plus 7. So here's our steps. We start out by grouping the x squared and the minus 4x together. Leave the plus 7, the constant on the outside. My next step is to figure out what number goes right here. Well, kind of a shortcut way of doing this. What I'm thinking is this. Here's the long way. I know it's an x and an x. These two numbers have to add up to be -4. Well, if they're going to be the same, I want it to be a perfect square, right? So if they're going to be the same and they add up to be -4, it's got to be a -2 and a -2. So the question is, what number do I have to add right here to make it so it actually factors? Well, we know that -2 plus -2 is -4, but when I times them, -2 times -2 is a +4. That would be a +4 right there. Well, as soon as I add that 4, I change the problem, so I have to compensate for that. So if I add 4 on the inside, I'm going to come to the outside and just subtract 4. Okay, all the hard work's done now. Oh, by the way, just a shortcut. You can figure out this number, that 4, it's always going to be that middle number divided by 2. So I take negative 4, I divide it by 2, and then you have to times it by itself. You have to square it, right? The negative 4 divided by 2 gives me the negative 2's, and then you have to times them together. So you have to square it. So that ends up being negative 2 squared. So that's a shortcut way of figuring out that that's got to be a positive 4. Okay, now we're going to factor it. So we're going to take that. Well, we know that's a perfect square now. So it's one of these. I know there's got to be an x there. What did I square to get 4? That was that negative 2. There's a minus there, so it's x minus 2 squared. Over here I have 7 minus 4 plus 3. Okay, now it's in vertex form. So if I had to graph it, I could. I know where the vertex is. The vertex is at 2, 3. I know it's opening up. There's a positive 1 there. So we could graph it from there. Hey, what I want you to do is I want you to pause the video and give this problem a try. See if you can put it in vertex form. And then when you come back, I'll go through it real quick with you. And then we'll do some that are a little bit trickier. So you group the first two together. Okay, you got to figure out what number goes here to make it a perfect square. You always take this middle number right there. Take that middle number. I divide it by 2 and square it. So 6 divided by 2 is 3. 3 squared is 9. I've got to add a 9 to make that a perfect square. Well, if I add a 9, I have to subtract a 9. I have to subtract 9 out there, right? 9 minus 9 is 0, so I haven't changed the problem. Okay, now we know that this part is now a perfect square because we just made it a perfect square. We're forcing it to be a perfect square. So what do I square to get x squared? What do I square to get 9? That was that positive 3 up there, right? There's a plus, so it's x plus 3 squared. On the outside, I have 4 minus 9, negative 5. We've got it in vertex form. My vertex then is at negative 3, right? We're going left 3, and we're going down 5. Okay, and we got our vertex. We could graph it from there if we wanted to. So hopefully that makes sense. If not, go back and watch those other examples. Make sure you understand that. I'm going to go through a couple more examples where there's a little bit of a twist to it. So make sure you've got this down before you go on here. So if you look at this next example, I've got y equals negative 2x squared plus 12x minus 11. I want to put that in vertex form. This one is different from the other ones we did. And the reason why it's different is because of that negative 2 out in front. So that changes things a little bit if you have a leading coefficient. It adds on a few extra steps. So I'm going to start out still with the first step is still the same. I'm going to group that negative 2x squared plus 12x together. Still have the minus 11 out there. Now be really careful. I can't go any further until I get rid of that negative 2 that's out in front. So this is a new step. I've got to take that negative 2 and factor it out. Now notice how negative 2 goes into both of them. Now, if you look at, they also have an x in common. Do not take out any x's. You only take out that leading coefficient. So I have y equals negative 2 times, and that leaves me with x squared. 12 divided by negative 2, so negative 6, parenthesis. Okay, now I'm down to here. Now I'm going to look at this inside part, and I'm going to complete the square. I'm going to do that step where I have to add the correct number there so that it will factor to be a perfect square. So I take the middle number. See if I can add another highlighter here that's a different color. Okay, so now I take that middle number, right? I divide it by 2, and I square it. Well, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I have to add 9 right there to make it a perfect square. That means out here, this is the trickiest part of the whole thing. So you got to really focus here. If you just subtract 9, that would be incorrect. And here's why. That negative 2 that's out in front, it's multiplied by everything on the inside. So when I added 9 there, it's really negative 2 times 9. Well, negative 2 times 9 is a negative 18. So I really added negative 18 to the problem. So out here, I need to add positive 18 to the problem. So see if that makes sense. Negative 2 times 9 is negative 18, plus 18 is still 0. That's what we want to happen. Okay, the hard stuff's all done. I just need to finish it up. It's negative 2 times. This part is a perfect square. So we know it's going to factor to be a perfect square. What do we square to get x squared? What do we square to get 9? That's this number up here. That minus is what makes that a minus. So it's x minus 3 squared. Minus 11 plus 18 plus 7. There's my vertex form. So the vertex is at positive 3, positive 7. Hey, if I were going to graph this, it's opening down, right? That negative 2 is opening down, which means that there's a little bit of a stretch too. So we'd have to take those into account when we graph this. Let me do one more of these just to make sure we have it down. Let's do this one right here. So y equals 3x squared minus 24x minus 10. If you want to and you're feeling confident, you can pause it here and try it yourself, and then compare it to what I end up with. Okay, but we're going to take the first two and group them together. Got 3x squared minus 24x minus 10. This leading coefficient, you can't have it there, so we got to factor out that 3. So factor out the 3. So I take the 3 out of the 3x squared, just be x squared. Take the 3 out of the 24. Remember, you're dividing by 3. So it'd be minus 8x. Okay, now I've got to add the correct number right there to make this a perfect square. So I take the middle number. That's the negative 8 right there. You always divide it by 2. You cut it in half. And then you square it. Well, negative 8 divided by 2 is negative 4. Negative 4 squared, negative 4 times negative 4 is a positive 16. Hey, by the way, because you're always squaring that, this always has to be a plus right here. Every time. Okay, now I added 16. That changes the equation, so I have to compensate for that. So what I'm going to do is just think, I have a 3 out in front. So when I added 16, that is really 3 times 16. Well, 3 times 16 is 48. So if I added a positive 48, out here I have to subtract 48. So 3 times 16 is 48, minus 48 is 0. We haven't changed the problem. Sorry. Okay, let's go ahead and finish this up. It's 3 times. I need to take this part and factor it. We know it's a perfect square. What do we square to get 16? That's this number, right? This is number right up here, that negative 4. So minus 4 squared. Minus 10 minus 48 is minus 58. Luckily, we're not graphing this, but if we were, the vertex would be at positive 4, negative 58. And then the 3 right there means it's going to be opening up, be a bit of a stretch there also. Okay, so that's the process. So again, if the goal we had for today, right, is to take an equation that's in standard form and rewrite it in vertex form. Let me know if you have questions, but hopefully that helps. Thanks, guys.